A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
What if I told you scientists just decoded the language of whales using AI? And it's not what you think. This isn't about cute noises or random splashes. It's a discovery that could change everything we thought we knew about intelligence on Earth. Whales are responding, orcas are organizing, and, according to some researchers, we may have been missing their warning for years. In one encounter, a whale continued vocalizing back to researchers as she swam away, almost as if saying, "Hey, maybe another time we could meet up." Even Tucker Carlson raised eyebrows when the news reached scientific circles. The ocean has been speaking, and now, for the first time, we're speaking back, but what the whales might be saying is a part no one saw coming. It all begins with a click, not from a keyboard or camera, but one echoing through the depths, bouncing off coral walls, and traveling for miles through open water. For decades, marine biologists have listened to these clicks, known as codas, produced by sperm whales, massive, deep-diving mammals with the largest brains of any creature on Earth. The clicks weren't random. They were rhythmic, intentional, and repeated with uncanny precision. The question was always the same: were they language or just noise? Scientists long suspected the whales were saying more than they let on. Some codas seemed to signal identity, like a personal name. Others hinted at emotional context, such as when pods reunited or calves called out to their mothers. But no one could fully understand the grammar or vocabulary behind the sounds. The technology simply wasn't there. For years, research relied on human ears, time-consuming spectrograms, and educated guesswork. It was like trying to decode Morse code in a foreign language without a key. Then everything changed. In recent years, marine bioacoustics collided with artificial intelligence, and the results have been staggering. One of the most ambitious efforts is Project Ceti, short for the Cetacean Translation Initiative, based in the Caribbean. Ceti unites experts in linguistics, AI, marine biology, robotics, and cryptography, all with a bold goal: to decode the language of sperm whales and, possibly, communicate back. They study whales in the waters near Dominica, home to stable, multi-generational whale families that allow researchers to track individuals, their relationships, and their unique vocal signatures over time. Armed with hydrophones and specialized tagging equipment, Ceti has gathered one of the most extensive sperm whale sound databases in the world, over 50,000 hours and counting. But the real breakthrough came when they fed these recordings into advanced machine learning models built on transformer architectures, the same kind that power cutting-edge language systems for human speech. When trained on whale vocalizations, the AI detected patterns, deep structural layers in the timing, pitch, rhythm, and spacing of the clicks that repeated within pods and varied between clans. The findings suggest something extraordinary. Whales may be using the building blocks of a complex language. Among the earliest discoveries, something eerily familiar to humans: dialects. Whales from one region produce slightly different codas than whales from another, and these variations persist across generations. Young whales spend over a decade learning their family's specific patterns, mimicking them much like children learning to speak. When males leave to join other pods, they often adapt to the dialect of their new group, shifting their vocalizations to match. That kind of flexibility is an instinct. It suggests cultural learning. Yet, for the scientists on Project Ceti, all of this is still just the surface. Every data point adds weight to a remarkable possibility. Sperm whales may have been speaking in a structured, meaningful way for millions of years, and we are only now developing the tools to understand them. If true, it wouldn't just change the way we think about whales. It would transform how we think about intelligence itself. They have been clicking across oceans long, before we built cities or carved letters into stone. The conversation was always there. The silence was ours. The breakthrough was one we weren't ready for. For most of modern science, decoding animal communication was a slow, grinding process. Researchers might spend years collecting a handful of vocalizations, watching behaviors, and forming a tentative hypothesis about what a single sound could mean. For people like Jacqueline Orban, who spent years analyzing beluga whale recordings in Canada, the work was painstaking, hundreds of hours listening to one call at a time, searching for patterns by hand. There were no grammar rules, no translation books, no shortcuts, just persistence and patience. Then artificial intelligence entered the equation. When Project Seti introduced machine learning into whale research, it wasn't just about automating data processing. It was about uncovering the hidden structure of a language no human had ever spoken. The models, built on transformer architecture that had already revolutionized human language translation, were now being trained on whale codas. What once would have taken decades to piece together manually could now be mapped in weeks. Entire lifetimes of audio could be digested, categorized, and compared in a fraction of the time. One of the first surprises came when the AI processed 8,719 sperm whale vocalizations. At first, researchers expected disorganized noise. Instead, the patterns that emerged suggested something far more sophisticated. The whales weren't simply repeating sounds. They were constructing them from consistent components. The AI identified 4 core elements that appeared across vocalizations: rhythm, tempo, rubato, and ornamentation. Rhythm referred to the spacing between individual clicks. A coda might feature evenly spaced clicks or vary between short bursts and long gaps. These differences seem to correspond to message urgency, with faster clicks often occurring in social or reunion contexts, and slower ones during what researchers call deep conversation exchanges. Tempo controlled the speed of the entire sequence, ranging from just over a second to nearly 5 seconds, with longer sequences following internal rules that hinted at hierarchy and complexity. Rubato, a term borrowed from music, described subtle timing changes that expressed emotion. Whales, like humans, appeared to speed up when excited and slow down when serious. Ornamentation referred to the addition of extra clicks or fluctuations at the end of a pattern. Far from being mistakes, these flourishes appeared in specific contexts, such as reunions between mothers and calves, and may function like emphasis in human language, adding emotional or social weight to a message. The picture became even more intriguing when researchers discovered that each whale group had its own version of common codas. These variations, differences in rhythm ornamentation, were described as dialects, consistently appearing within certain pods but not others. They weren't accidental. Data showed that young whales spent more than a decade learning these dialects from older family members, and in some cases, adult males who migrated to join new pods adapted their vocalizations to match the group style. For scientists, this was stunning. Such vocal flexibility suggested not just instinct, but a deep awareness of social context and the ability to change behavior to fit in, akin to humans deliberately adopting a new accent. The AI hadn't just revealed how whales speak. It hinted that whales might consciously choose how they speak depending on who they are with. That realization shifted the conversation from communication to culture. According to some researchers, this pointed to a form of cultural intelligence, a system of inherited knowledge passed down through sound. For Project Seti, the breakthrough didn't answer all the questions, but it dismantled the long-standing assumption that humans are the only species to shape and evolve language over generations. If whales have dialects, grammar, and emotion in their speech, the next question became unavoidable. What are they actually saying? And perhaps more importantly, are they ready for us to understand? Listening was only the first step. Project Seti wasn't built just to catalog clicks and rhythms, to map syntax, or to piece together the grammar of an ancient language echoing across the sea. It was built to see if we could respond. Not mimic, not replay, but generate entirely new whale vocalizations that had never existed before, using the whale's own grammar. Would the whales understand them? Would they care? By the time the AI had processed thousands of codas, it had learned enough about timing, rhythm, and emotional cadence to construct synthetic codas that follow the rules of sperm whale communication without copying any real whale's voice. These were, in effect, original sentences created by a machine for another species. The moment was not without hesitation. Scientists knew they were crossing into active interspecies communication, using a language they didn't fully understand. But the potential payoff was too great. If the whales accepted the AI-generated codas as legitimate, it would be strong evidence that the underlying structure of their language had been at least partially decoded. The test took place in a quiet stretch of water near Dominica. Researchers positioned their vessel close to a pod of acoustically tagged sperm whales whose vocal patterns had been studied in detail. Through submerged speakers, they played several AI-generated codas, reunion calls, greeting sequences, and social engagement patterns, each tailored to match the specific dialect of that pod. Then they waited. According to preliminary findings, the results were astonishing. 68% of the time, the whales responded. When the AI played a reunion call, mothers and calves swam toward the vessel. When a greeting coda was played, the pod paused, emitted returning codas, and in some cases lingered longer than usual. Some scientists believe this indicated recognition, not just of the sounds, but of the intent behind them. While it remains impossible to say whether the whales believed they were speaking to another whale or simply recognized a familiar structure, the consistency of their reaction suggested more than idle curiosity. Remarkably, these responses weren't limited to one pod or one type of coda. Multiple families displayed similar behavior. The AI system was not only producing grammatically correct whale speech, it was generating vocalizations that the whales appeared to treat as meaningful. It was as if a door had creaked open. For the first time in history, humans had spoken to whales in their own language, and the whales had answered. But it didn't stop there. In the days following the playback tests, researchers continued to monitor the tag whales. They noticed subtle shifts in vocal behavior, changes in pacing, slight alterations in ornamentation, and what seemed to be echoed codas resembling those played from the boat. Some scientists suggested this could be the start of a back-and-forth exchange, though others cautioned it might be coincidental. Still, the possibility that the whales weren't just responding, but actively engaging, left the team speechless. This was no parlor trick or publicity stunt. It was a scientifically controlled attempt at conversation, and it had worked. According to Project SID's team, the implications were enormous. Humans were no longer outsiders with microphones. We were participants. For generations, we had assumed we were the only species on Earth capable of language. Now, that assumption had been shattered. The AI hadn't just cracked the code. It had spoken, and against all odds, the whales had decided to listen. At first, the focus was entirely on the breakthrough itself. AI-generated codas receiving responses from real whales. That alone felt monumental. But as researchers continued feeding data into the model, new patterns emerged, patterns that raise an entirely different set of questions. If we were beginning to understand how whales communicated, perhaps it was time to ask what they were actually saying. The AI had already mapped the structure of whale codas, the rhythm, tempo, rubato, and ornamentation, but now attention shifted to context. Researchers compared codas recorded near boats, fishing zones, and shipping lanes with those recorded in quieter, undisturbed areas. The differences were subtle yet consistent. One pattern in particular caught their attention, a string of rapid, rhythmically complex codas, often emitted in sequences of 3, followed by a long pause. These vocalizations were almost never heard during social bonding or feeding. Instead, they occurred almost exclusively near active ship routes. Preliminary findings suggested they could serve as warning signals or boundary-setting cues. The whales weren't calling to family members. They were responding to us. Some scientists believe these sounds might be more than simple stress reactions. One hypothesis under review proposed that certain pods had developed codas specifically in response to repeated interactions with human activity. In other words, whales might be evolving new communication strategies to deal with a changing world. The story became even more intriguing when the AI cross-referenced these codas with known whale movement data. In regions with heavy ship traffic, the same vocalizations were being repeated by multiple pods, some of which had never interacted before. It was as if a message had started to spread. A few researchers hesitated to draw conclusions, but others began to wonder, what if this was the start of a coordinated acoustic behavior, a kind of interpod alert system? If true, the implications would be staggering. It would suggest that sperm whales are capable of cultural learning not only within family groups, but across them, sharing information about threats or boundaries through a distributed language network. While Project SETI's team stressed it was too early to confirm such a discovery, one phrase began circulating internally. This changes everything. This wasn't just about whales making noise near ships. It was about whales possibly developing new language to respond to modern threats. That would mean they were not only aware of their environment, but actively adapting their culture to meet it. In other words, we may have just decoded the first example of whale diplomacy. And here's the most unsettling part. Scientists have used AI to decode whale language, and the results are not what anyone expected. Instead of finding only symbolic sounds, emotional cues, or rudimentary vocabulary, the data revealed signs of agency. Whales may be using language not just for social interaction, but to set limits, express territorial claims, and say, in effect, this space belongs to us. Some scientists now warn that continued acoustic intrusions like sonar and underwater drilling could be disrupting these boundary codas, interfering with a system we barely understand. If we've misunderstood their warnings, how many other messages have we already missed? The realization is sobering. The conversation we stumbled into might not be one of welcome, but one of negotiation. And if that's true, this is not only a scientific breakthrough, it's a moral reckoning. We're no longer the only voice in the ocean. We're not just studying whales. We are in dialogue with them, and they might have been trying to reach us far longer than we ever imagined. While sperm whales are quietly revealing the structure of an ancient, organized language, another species has been making headlines for a very different kind of communication. Off the coasts of Spain and Portugal, orcas have been systematically attacking boats. And according to researchers, this behavior isn't just spreading, it's evolving. The first incidents began in 2020, when a few young orcas were observed bumping and circling sailboats in the Strait of Gibraltar. At the time, most scientists assumed it was playful behavior, perhaps sparked by the pandemic's quieter seas. But as the years passed, the behavior intensified. By 2024, over 670 documented cases had been recorded, including at least 4 vessels that were completely sunk. This is not random aggression. Marine biologists note that 93% of the attacks come from just 2 family pods, mostly involving juveniles and subadults. More strikingly, a single female, nicknamed White Gladys, has been identified as a likely origin point. She may have experienced a traumatic encounter with a vessel, and her response appears to have spread as a socially learned act of resistance. Equally remarkable is the communication surrounding these attacks. Orcas have been recorded using distinct vocalizations before and during the encounters. Underwater microphones have captured pods converging on targets with long-distance whistles, sometimes heard more than 5 miles away. During attacks, they emit synchronized buzzing sounds at higher frequencies, followed by coordinated calls after successfully removing or damaging a rudder. This suggests they are not only learning the behavior, but possibly developing a new acoustic system around it. Some researchers call it a real-time cultural cascade, while others argue that these calls are distinct from any known orca sounds, meaning they might be creating new forms of encoded communication. The contrast between sperm whales and orcas could not be more striking. Sperm whales demonstrate an ancient, stable communication system passed down over centuries, ceremonial and deliberate. Their codas have remained consistent over time, their families speak in dialects, and their young spend more than a decade learning proper communication, a hallmark of long-term cultural preservation. Orcas, by contrast, are innovators. Their calls shift depending on pod identity, hunting strategy, or environmental change. And now, in the case of the Iberian attacks, they appear to have applied that adaptability to conflict. What began as a possible reaction to trauma has turned into a viral behavior. Like a human meme, it has been picked up, remixed, and spread from group to group, spanning over 700 miles of coastline. Some scientists believe this may be one of the clearest examples of animal culture evolving in real time, while others urge caution, pointing out that although the attacks are clearly coordinated, we still don't know if the vocalizations used during them meet the full criteria of language. But almost everyone agrees something extraordinary is happening. The orca attacks raise unsettling questions. Are we witnessing the birth of a new dialect, a strategy, a warning? Could these events be more than a reaction? Could they be a message? If so, what are they trying to tell us? For centuries, we have studied animals as isolated specimens, but these recent events suggest something different, an interconnected world of non-human minds, constantly learning, adjusting, and responding to us. Not as background noise in the ecosystem, but as conscious participants. As the data keeps pouring in, one truth becomes harder to deny. Intelligence is not ours alone. And the other species sharing this planet with us are no longer silent. They are starting to speak in their own ways. The question is, will we recognize it in time? Are we ready for the conversation? We have crossed the line quietly, perhaps without realizing it. For the first time in history, humans have begun to understand the language of another species, not through imagination or instinct, but through data, algorithms, and acoustic patterns decoded by machines. Sperm whales are teaching us that language can exist in forms we never expected, carried not by words, but by rhythm, tempo, and intention. Orcas are showing us how fast behavior, and possibly even language, can evolve when intelligence meets pressure. According to researchers at Project SETI, their ultimate goal is not simply translation, but dialogue. They hope to identify at least 50 functional words by 2027, map grammar rules, and eventually create the first tools for real-time interaction. Some scientists believe we are on the cusp of interspecies communication that would have been pure science fiction a decade ago. But the technology is advancing faster than our ethics. If whales can tell us where they are going, what they need, and what they want us to avoid, do we have a responsibility to respond? Early whale tracking systems using acoustic prediction are already reducing ship strikes, and AI models can forecast surfacing areas with high precision. Conservationists are beginning to ask, should shipping routes change if whales are asking us to stay away? And what about the orcas? The Iberian boat attacks may not be random. Some researchers suspect they represent a kind of protest, a warning delivered in the only language we are likely to notice: damage. If that's the case, we're not just studying animals anymore. We're negotiating with them. These breakthroughs are thrilling but also unsettling because they force us to confront the possibility that we have ignored voices in the ocean all along, voices with memory, emotion, and something important to say. Scientists have decoded the language of whales using AI, and it's not what you think. This isn't about novelty or clever algorithms. This is about recognizing intelligence that has always been there beneath the waves, speaking in clicks and echoes, waiting for someone to finally listen. And now that we have answered back, the only question left is, are we ready for what comes next?